So let's look at how a solution might form. We can think about it happening in 3 steps. Step 1 is the solute separating into individual particles. The solute is, these particles are attracted to each other. If this is a solid, that's the reason it's a solid, because they're attracted to each other. So we have to get them away from each other. That's going to require us to put energy in to separate them, right? Because they like being together. They've got intermolecular forces holding them together. So this is always going to be endothermic. So here, delta H is going to be positive. We have to put energy into the system. The second step would be taking the solvent particles and separating them and making space for the solute particles. So this kind of looks like water to me, because it's blue, I guess. But we need to make some space here. Well, these molecules are also attracted to each other by intermolecular forces. And so to spread them apart is going to require us to put energy in. This is also endothermic. So delta H for separating the solvent, also greater than 0. And then we can take the separated solute and separated solvent particles and mix them together and allow them to interact with each other. So this is going to be exothermic because there are forces of attraction between these. And as these are attracted, it's going to release energy into the surroundings. So delta H for the system is negative. We're calling that delta H mix for the mixing. So then the enthalpy change for the solution, for making the solution, will be the sum of all of those changes. Whether this is positive or negative is going to depend on the magnitudes of those, because we have 2 that are positive and 1 that's negative. But if the negative one is really big, this could be exothermic. If the negative one is kind of small, this might be endothermic. So forming a solution can be exothermic or endothermic. And this is one of those Born-Haber cycles. Here thinking about, so we've got the solute particles and the solvent particles aggregated, meaning they're together. We put energy in to separate the solute particles. We put energy in to separate the solvent particles. And then when we let them mix, it releases energy. In this case, the sum of these 3 purple arrows is greater, is more negative, and so this is an exothermic process. And this is a similar thing, but here the positive values end up overall being bigger than the negative, and so it's an endothermic. Well, if we're talking about an aqueous solution of an ionic compound, we can combine delta H for the solvent, that's the energy needed to separate the water molecules, and the mixing part into what's called the heat of hydration, or delta H hydration. Basically, the heat involved in getting this thing wet. That is the enthalpy change that occurs when 1 mole of separated solute ions dissolve in water. This heat of hydration is always going to be negative and quite a lot negative. It's going to be exothermic because when these ions and water molecules come together, they're going to experience ion dipole forces, which are a lot stronger than the hydrogen bonding that the water is giving up. Any questions? Besides, what the heck are you talking about? For ionic compounds, delta H of the solute, that's the energy needed to separate the particles of the solute into particles in the gas state. That is the same value as the lattice energy. Lattice energy was the energy when a bunch of gaseous ions go whoo, right? That was the noise, whoo, and they all come together, and that releases energy. So delta H solute is just doing the opposite, taking those and pulling them apart. So if delta H for the solute is smaller than delta H for hydration, the absolute values of those, the solution formation will be exothermic, and as you make the solution, it will appear, it'll feel warm. It'll be warmer than the surroundings. If delta H for the solute is larger than delta H for the hydration, then the process will be endothermic, and the solution will feel cool. And these are the sorts of reactions that occur in those instant ice packs, where there's a salt in there and some water, and you break the seal, and as it mixes, it absorbs energy from the surroundings.